Hey there, welcome to Galileo's AP STEM. Today we're covering topic 3.3 of the AP Calculus curriculum, so if your mind's ready to function, let's learn how to differentiate inverse functions. First, what is an inverse function? An inverse function reverses the effect of the original function, meaning it swaps the input and output. This means that if f of 1 equals 2, then for the inverse, f of 2 must equal 1. Let's take a look at this table of values. Let's assume that this table represents f of x. So then what do you think the table of the inverse function would look like? That's right, the x and y values would just completely switch. A similar concept applies to the slope, because the slope of the inverse is equal to the reciprocal of the original function. Now let's look at the definition of an inverse. The definition states that if you plug a function into another function and you get x as a result, then that function is an inverse. Now that we've reviewed inverses, we can get onto what's actually on the exam. May I introduce to you the inverse derivative formula? This is used to find the value of an inverse derivative function at a certain x value, or in other words, we're trying to find the slope. And I know the formula is big and scary, but don't worry, we'll do some practice problems and you'll master it by the end of this video. Here we have an AP style question that you are likely to see on the exam. F is a differentiable function. If g is the inverse of f and f of 1 equals 4 and f prime of 1 equals 2, what is the value of g prime of 4? So upon reading this, you might think, how on earth am I supposed to find the slope of something that I don't even know the equation to? But we can use the inverse relationships that we've learned to find the answer. So first, let's establish that if f of 1 equals 4, then g of 4 must equal 1. Now we can use the formula to find the value of g prime of 4. So using the equation, g of 4 equals 1, and as we already know, f prime of 1 equals 2. Therefore, the answer must be 1 over 2. Now let's look at another example. Here we have the function x cubed plus 2x plus 1. And our main objective is to find the inverse derivative value at 4. Since we're trying to find the y value at g prime of 4, we can make the statements g of 4 equals something and f of something must equal 4. Using this logic, we should set the original function equal to 4 to find the x value at this point. Just looking at this equation, it would make sense that an x value of 1 would give us a y value of 4. Therefore, we can confidently say that g of 4 equals 1, but we can't use the shortcut formula yet because we still need to find the derivative of the original function. X cubed goes to 3x squared, 2x goes to 2, and 1 obviously goes to 0. From here, we can plug in 1 to the derivative, which will give us an answer of 5. Now, just like the last problem, we have all the information we need to plug these numbers into the inverse derivative formula. G of 4 equals 1, and f prime of 1 equals 5. Therefore, the answer must be 1 over 5. And just like that, you have learned how to differentiate inverse functions. Now, if you want to learn about inverse trig functions, then go ahead and subscribe and check out the next video. I'll see you in the next one.